13.8 billion years ago, the universe exploded into existence. But some physicists think that wasn't the whole story. They suspect our Big Bang might have a twin, a mirror universe that expanded in the opposite direction in time, where everything runs backwards from our point of view. Not just eggs uncracking, but entire galaxies evolving with reverse time's arrow. This isn't science fiction. It's a serious attempt to solve some of the deepest puzzles in cosmology. Why time seems to flow one way, why there's so little antimatter, and what dark matter might actually be. To understand the mirror, you first have to look very closely at the bang. The Big Bang is not an explosion in space. It's an explosion of space. Wind the cosmic clock back, and galaxies don't fall into a central point. The distance between every pair of galaxies shrinks, because space itself is contracting. Extrapolate far enough, and you reach a state of extreme density and temperature, where our current physics breaks down, the so-called initial singularity. But there's a problem. The equations of our best theory of gravity, general relativity, don't actually demand a hard beginning. They just say that if you go back far enough, the math stops being trustworthy. So what if, instead of a wall, the Big Bang is a doorway? To see why that idea is tempting, you need to think about time itself. At the microscopic level, the fundamental laws of physics are almost perfectly time-symmetric. If you filmed two particles colliding and then played the video backwards, the reversed collision would still obey the equations, yet your everyday experience screams that time has a direction. You remember the past, not the future. Ice cubes melt, they don't spontaneously assemble in warm water. This arrow of time is tied to entropy, the measure of disorder, which, as far as we can tell, always increases. For the arrow to exist, the early universe had to start in an incredibly low entropy, exquisitely ordered state. That's weird. Why should the universe begin so improbably tidy? One radical answer is, maybe it didn't begin at all. Maybe the Big Bang is a special moment in a larger, symmetric structure. Imagine time not as a line with a starting point, but as a smooth curve with a minimum. On one side of that minimum is our universe, expanding and aging in the direction you call forward. On the other side is a mirror universe, also expanding, but its forward time points the other way relative to ours. From our perspective, that side looks like it's running backwards. From their perspective, we're the ones going backwards. Crucially, both sides start from the same ultra-ordered, low-entropy state at the bang, and then evolve away from it, so entropy increases in both directions. This idea becomes sharper when you bring in a principle called CPT symmetry. In quantum field theory, if you flip three things at once, charge, parity, and time, the laws of physics should look exactly the same. Charge means swapping particles with their oppositely charged partners. Parity means reflecting left and right, like in a mirror. Time means running the movie backwards. Some researchers, like Neil Turok and collaborators, have asked, what if the entire cosmos respects CPT symmetry on the largest scale? Then our universe, with its particular mix of matter, expansion, and time direction, would be only half the story. The other half would be a CPT-reflected universe, time reversed, mirror flipped, and with matter replaced by antimatter. In a CPT-symmetric cosmology, you don't have a singular beginning. Instead, the Big Bang is a smooth, symmetric point where the scale factor, the thing that measures the size of the universe, reaches a minimum and then grows in both time directions. On our side, we see an expanding universe filled mostly with matter, a tiny amount of antimatter, and a mysterious dark matter component that outweighs normal atoms by about 5 to 1. On the mirror side, you'd have the opposite, mostly antimatter, a tiny sprinkle of matter, and its own version of dark matter. Each side's arrow of time emerges naturally from the low entropy state at the bang, without needing a special one-sided initial condition. This symmetry isn't just philosophically neat, it might explain real observations. Take dark matter. In CPT symmetric models, some of the particles we usually ignore, like very light right-handed neutrinos that barely interact with anything, can naturally play the role of dark matter. Their properties are constrained by the requirement that the whole universe, including its mirror twin, respects CPT. That gives you specific predictions For example, a particular mass range for these neutrinos, and a particular pattern for how they affect the cosmic microwave background. The faint afterglow of the Big Bang, now cooled to about 2.7 Kelvin. Cosmologists can then compare those predictions to precise satellite measurements. So far, the data don't rule out a CPT symmetric mirror universe, but they don't prove it either. The cosmic microwave background is astonishingly uniform, with tiny fluctuations at the level of 1 part in 100,000 different cosmological models. Inflation, bouncing universes, mirror universes can all be tuned to reproduce those fluctuations. The real test comes from subtle details: how the temperature variations correlate across different angular scales, how structures like galaxy clusters grow over billions of years, and how neutrinos influence that growth. Upcoming surveys, mapping tens of millions of galaxies and measuring the polarization of the microwave background even more precisely, could tighten the net around these theories. But even if the math works, what does it mean physically to have a mirror universe before the Big Bang? You can't send a probe there. You can't wait for a signal. From our point of view, that side lies in what we call the past. The connection is purely through shared laws and boundary conditions. Think of the Bang as a two-sided mirror. On one side, you, galaxies, and an arrow of time pointing away from the mirror. On the other, an anti-you, anti-galaxies, and their own arrow, also pointing away. Neither side can cross the mirror, but both are part of a single, larger time-symmetric cosmos. It's a universe where before the Big Bang isn't nonsense, it's just the other side. The biggest open question is whether this beautiful symmetry is real or just a clever story our equations allow. Does the universe truly have a CPT symmetric twin, or will future data force us toward a different explanation for time's arrow, dark matter, and the low entropy beginning? Right now, we don't know. What we do know is that every time we've assumed the universe is simpler, more symmetric, and more elegant than it looks at first glance, physics has rewarded us. Until we can test these ideas more brutally, the mirror universe remains what it is today, a reflection at the edge of our understanding, daring you to ask which way time is really flowing. And that's the kind of question we live for on Terra Nova.